Alright, let's graph some square root functions. Certainly you know a lot about square roots and how to find them. Of course, we want to look at the graph of the square root. So we're going to do that first by plotting a bunch of points. We know that we can pick 0 for x, and the square root of 0 is 0. The square root of 1 is 1, and the square root of 4 is 2. If we tried to pick any negative numbers, like -1, square root of -1 is I, and that's imaginary. So there's not going to be any real f of x value. So we're not going to be able to plot a point when x is negative. But we can plot them when they're positive. And we see that when we got 0, 0, 1, 1, and 4, 2, we get this arc. Actually, this arc should look kind of familiar because it's like half of a parabola. It's just the top half. That's because when we take the square root of a number, we only get the positive value. We're not getting that negative value. But looking at our graph, we could see a few things, some characteristics about the square root function. First of all, its shape. We see that it starts at this most important point at the origin and then moves up and to the right. That means that its domain, we're used to it being all real numbers, is not going to be all real numbers anymore. Now all of these x values are going to be greater than or equal to 0. The range, the f of x's, the y values, those are also going to be greater than or equal to 0. As far as the intercepts go, the x-intercept and the y-intercept are both at the same point. They're at the origin. And then when it comes to the end behavior, what happens as x approaches infinity? So as x gets bigger and bigger and bigger, if we take a square root of a larger and larger number, the square root also gets larger and larger. So f of x is also going to approach infinity. The transformations that we see in the square root function are very much the same as the ones that we saw when we were dealing with parabolas and absolute values. The horizontal shift, if we're dealing with f of x is equal to a, some constant, times x plus h plus k outside of the square root, the horizontal shift is going to come from that h, and we do the opposite of whatever that h says. The vertical shift is going to come from the k, that number that's being added outside of the square root. If we take a look at what that means for the graph, I've graphed the parent graph in black here. If we have a horizontal shift of the opposite of whatever h is, and the vertical shift of k, that's going to move our starting point somewhere else to this negative h k. Not that h has to be a negative number, just the opposite of what's inside of there. But then the rest of the graph is going to flow from that starting point. For instance, to go from 0 to the next important point, we went over 1 and up 1. We could do that here as well, go over 1 and up 1. And then we went over 4 and up 2, so over 1, 2, 3, 4 and up 2. And we'll get that same half of a sideways parabola. It's just that it's starting from a new point. Any vertical reflections or stretching all has to deal with that constant that's out in front of the square root, that a. And the vertical reflection will happen if that a is negative, it's less than 0. So if we're dealing with y equals the negative square root of x, then we're still starting in the same spot. It's just that instead of the y coordinate being 1, it's going to be -1. Instead of being 2, it's -2, which will give us the bottom half. A vertical stretch is what a is. So if it's the absolute value of a, I guess is what we should call it. So that if we have 2 times the square root of x, let me change my color here, then instead of having a y value of 1, it's going to be twice as big. So 1, 2 up to here. And instead of having a y value of 2, it would have a y value of 4. So it gets doubled at every one of those important points. So we'll have that vertical stretch if that constant term in front is a number other than 1. So let's graph a couple. If we're looking at f of x is equal to the square root of x minus 2 plus 4, our starting point has moved from the origin. The x-coordinate of our starting point is going to be the opposite of that -2, so +2. It's actually the value that's going to make what's inside of the square root equal to 0. Then +4 is our y-coordinate. So we're going to go start at over 2 and up 4. Since our coefficient out in front is equal to 1, that means that the path of our curve is normal, that we would go over 1 and up 1, and over 4 and up 2. And now we have that sideways parabola that we'd expect. If we're going to graph f of x is equal to -2 square root of x minus 1, again we got to think about where we start. It's going to be an ordered pair, where the x-coordinate is actually what's going to make what's under the square root, the radicand, equal to 0, and that would be 0. The y-coordinate of where our starting point is going to be this -1 that is on the outside. So we're going to start at 0, -1. Now, normally, how the curve progresses is we go over 1 and up 1, or over 4 and up 2. But we need to take into account that a, our coefficient out in front, is -2. So that means that instead of going over 1 and up 1, we're going to take that up 1 and multiply it by -2. Right? That would turn into a -2, which means when we go over 1, we're going to go down 2 units. That up 2 that we normally do, we're going to multiply that by -2 as well, which turns into a -4. So when I went over 4 and up 2, now I'm going to go over 4 and down 4. 1, 2, 3, 4. And so this is that half a parabola that we're going to use here. We won't need any of that stuff there. On a side note, I also want to show you how to solve an equation when it has a square root in it. What's going to be very important is to get the square root alone first. So here I'm going to add 6 to both sides. Now, a common mistake is we see that square root, and so we want to take the square root of stuff, especially if this 11 is a nice perfect square like 16 or 25. But in order to get rid of a square root, we have to do its inverse, square both sides. That means that 11 squared is going to be 121, and the square root of x plus 4 squared, these cancel, leave us with x minus 4. So we finish this up by adding 4 to both sides, and x is equal to 125. Of course, you can always check that answer by taking it, plugging it back into the original, and seeing if 5 is equal to the square root of 125 minus 4 minus 6. Well, 125 minus 4 is 121, which square root of 121 is 11, and 11 minus 6 is 5. 5 is equal to 5, and so we are correct.